Today I'd like to take a look at graphing numerical data, and in particular we're going to be looking at dot plots and stem and leaf plots. So go ahead and open up your note section to dot plots and stem and leaf plots under graphing numerical data. Now let's begin with dot plots. When dealing with numerical data sets that are fairly small, a dot plot gives us a nice visual display of our data. We can then talk about certain features of the distribution of the data that are going to be important to us later, and we'll discuss those features later on, and in particular we're looking at center and spread and shape and maybe any unusual occurrences as well, but we'll refer to those later in this chapter. But dot plots are nice ways to display numerical data as long as our data sets are not too large. Now let's take a look at an example here. The dot plot here below represents the number of ways to achieve a certain sum as we roll a pair of dice. For instance, the only way I can roll a 2 is for each die that I have to show up with a 1. There's only one way to roll a 2. There's 2 ways to roll a 3. I can get a 1-2 or a 2-1, so forth and so on. There's 3 ways to roll a 4, and if we go all the way up to the highest number of frequency count in our dot plot, that's 7. There's actually 6 ways to be able to roll a 7, and then it starts working back down. So this is a dot plot representing the number of ways that we can roll a particular sum with a pair of dice. Now, when creating a dot plot, the first thing that we want to do is draw a horizontal line or horizontal axis and mark it with an appropriate measurement scale. This will all be dependent upon the type of problem that you're doing or the type of dot plot that you're creating. So you have to take a look at the range, or actually the domain of possible values that could occur with your dot plot in your data. Now once we've drawn the horizontal line and marked it with the appropriate measurement scale, we want to next locate each value in the data set along the measurement scale and then represent it by a dot. So we're going to place a dot above the appropriate place on the measurement scale there, and typically on dot plots we go by whole number values. It doesn't necessarily need to be that way, but typically we can use continuous data and chop it off or truncate it or round it and use that to represent measurements for a dot plot as well. Now, step 3, if there are 2 or more observations with the same value, then we're going to stack the dots vertically. So once again, to create a dot plot, we draw a horizontal line and mark it with the appropriate measurement scale. Then we locate each value in the data set and represent it by a dot along the measurement scale, the horizontal axis. And once we start seeing repeated values, or if there's more than one value, we go ahead and stack those dots vertically. Now let's take a look at the dot plot below. The dot plot below represents the weights of a sample of students. Notice that we had most of our observations, that the most frequently occurring observation, which turns out to be the mode of our distribution, is at 140. Many occurrences occurred at 140. We could take a look at the range of values. Our lowest weight appeared to be about 103 and our highest weight appeared to be about 239. And we can take a look where the bulk of the data is. So it's a very nice visual display of our numerical data that gives us some type of idea of perhaps the shape of the distribution, where the center of our distribution may be, perhaps what the spread of our data looks like, and perhaps if there's any unusual happenings that we find within the data set itself. So once again, dot plots are very good visual displays. We can begin now to investigate important features such as center, shape, spread, and unusual occurrences that are displayed in our distribution. And once again, we're going to be talking about what we're looking for in graphical displays with numerical data, and we'll devote one whole section to the important features that we talked about in this bullet here: center, shape, spread, and unusual occurrences. Now we can also do comparative dot plots. Perhaps we want to break out our data by another particular variable. Perhaps we want to go back and take a look at the weight data, and in this case split it out by gender. We can use a comparative dot plot where we basically stack the 2 dot plots one on top of the other to take a look at a comparison in the distribution of data. So obviously when we look at the 2 data sets here, if we want to compare them, the weights of males and females, we just stack them on top of one another using the same scale. Now we can compare the differences and important features of our graphical displays.